So Sam, you started STEM this year. Tell us about what the first project you did and how you set it up.
Well, I did a CREST experiment to see if crabbing the seeds together changes the growth due to competition for light and water. So I got 4 discs and I put different numbers of seeds in each one with a certain amount of cotton wool and a certain amount of water. And then I just waited for 2 weeks and see,
So what was your hypothesis then, and what did you measure after those 2 weeks?
Well, I thought the more seeds you have, the longest ones will grow due to the competition for light.
And this is what you found out?
Yeah.
So tell us, what's the trend of your results that you've got from your graph?
Well, it corresponds quite well with my hypothesis, increasing as the number of seeds increases.
Great, so you've illustrated quite quickly that competition does stimulate different growth in seeds. And this could be important, obviously, as you've talked about, for farmers and how to grow things, how to maximise yield. What were some of the problems or things you wanted to change from your project?
Well, I really want to do some more repeats next time, just to make it more reliable.
Yeah? Anything else you wanted to change?
I think just have more results, because I only have 4 points on the graph.
Absolutely, to increase the credibility.
Yeah, credibility.
And you've moved on from that to another project at the moment. Tell us a bit about what you're going to do and how maybe you've modified it from your previous one.
Well, I'm trying to find out which substances are the best antibacterial kind of repellents.
Right.
So I'm using onion, garlic, potato and penicillin disc. And I'm going to measure the longest length in the zone of inhibition and take an average from different lengths in the zone of inhibition.
You're going to grow bacteria and see which of these repel the bacteria the more. And how have you modified this project in light of doing the previous one?
I think I've put more effort into the variables, because I've purposely asked Dr. Bass to get some Micrococcus luteus plates, so it makes it more reliable because it's the same type of bacteria.
So controlling variables more, and what else?
Well, I've written an actual method out instead of the last one where I didn't write an actual method out.
Good, so this is a bit more organised, and you know what you're doing in terms of controlling variables and doing repeats.
Yeah.
Good. So you've set up, Chris, and you've set up a similar experiment to Sam, who I just spoke to. We can see here your results of the lower density, the higher density of number of seeds per jar. Do you want to explain what you found out from your project?
I found out that the jar which had the most seedlings in it, the length of the the stem had grown the most, whereas the jar with the fewest number of seedlings in had almost no growth whatsoever.
Now, how long did you leave these for?
I left this for about 3 to 4 weeks, and what I found was that there was significant bacterial and fungal growth that was affecting my investigation because it wasn't being controlled.
Right, so you found something different that you didn't expect, and these have been left down for weeks now, haven't they? So why haven't you put them away? Why haven't you got rid of them?
Well, this got me interested in thinking what we could do with bacteria, and I decided to take up another project, testing whether music affects the growth of a bacterial colony.
Right, so this hasn't really been done before,
no,
so this will be something, and do you know what you expect from the results?
No, I have no hypothesis whatsoever. But I think the results should be quite interesting, just for a bit of fun.
And how will you compare the two fairly?
I think what I'll do is I'll measure, so because some of it is fungal growth, I will probably redo this experiment under a more controlled environment. So I will have a petri dish with a bacterial broth, and one with the same conditions but also has the addition of music being played to it. So although it's not the most effective technique in keeping the test fair, it should be fair to a certain extent. To
be able to see valid results. Yeah. Good, thank you.
So in STEM this year, first of all I looked at plants, but after that we started looking at bacteria. First of all, I took swabs from around the lab and outside the lab, and then swabbed them onto little petri dishes to see how bacteria would grow. As you can see, some of them show very clearly nice patches of bacteria which show up against the petri dishes and the agar jelly. After this, we started looking at antibacterial properties of different things, such as penicillin, penicillin shows a very strong zone of inhibition around the penicillin tablet when in agar jelly with Micrococcus luteins inside to ensure that bacteria would shop around. We also compared different forms of antibacterial agents. For example, here you can see penicillin is much more effective than garlic. Around penicillin, the zone of inhibition is very large, and there aren't many bacterium there at all growing, whereas by garlic, there is bacteria growing around it. Penicillin overall showed a very good antibacterial properties, and the zone of inhibition was very clear. However, when compared with streptotin, which wasn't so effective, it was much clearer to see that penicillin was more effective than streptotin.
I looked at the effects of different antibiotics and their effect on bacteria. So here we have penicillin, and you can see that penicillin has a very little zone of inhibition. It could suggest that penicillin has very little antibacterial properties. And here I grew Micrococcus luteins with streptomycin, which is another antibody like penicillin, and you can see it's got much bigger and clearer zone of inhibition, which shows that it's got more antibacterial properties. And here there is a ring of antibiotics, so there's loads of different substances that contain antibacterial properties. And if you see, for example, like the purple one at the top right here, it's got a much bigger zone of inhibition compared to the pink one. So it suggests that the purple substance has more antibacterial properties and is able to kill off the bacteria. What I will need to do now is to measure the zone of inhibition and compare them with the other substances.